Hello, hi everyone. My name is Nehel and welcome to the stream by OneClass. Today we'll be solving some physics questions, and these questions would be typically of the high school to university level questions. Just a little bit about myself. I went to University of Waterloo and I studied mechanical engineering there and I graduated in 2018. As part of the curriculum at Waterloo, I completed 6 co-op terms and I've been working in the plastics industry for the past 2 years. Uh, Up next for me is that I'll be starting my master's degree at the University of Toronto, also in mechanical engineering, basically from next week. So yeah, really looking forward to that. And without further delay, let's get into and solve some physics questions. All right. So question number one is saying a cart has a mass of and moves in the right direction. Show how to calculate the work done for each case. So in this question, we need to know, in order to solve this, the formula for work, which is force times displacement. Um, and there's one important concept which we need to know is that work done is only for the force which is acting in the direction of the displacement. So I'll show that to you in a second. So let's get started and solve the first part. So for part A, we have a box. We know that our displacement, so our S is in the right direction, and our force is also acting in the right direction. So work done is given by the formula of F dot. So the important part here to note is the dot product, which essentially says that take the component of the force along my displacement. So since in this case both the force and the displacement are in the same direction, we can simply multiply them. So in this case we would get 10 times the displacement, which is 1.5. So we would get 15 joules as the work done. Okay, so the first part we simply multiply force and displacement. For the second part, the force is actually not entirely in the direction of the displacement. So for the second part, we have a force of 10 Newton acting at an angle of 30 degrees from the horizontal. Okay, so in this case, our displacement is still in the same direction, but a force is acting at an angle. So what we would have to do is we would have to resolve this force into two components and then take the product of the component of the force which is along the direction of the displacement with the displacement in order to get the work done. So in this case, since the way you would resolve in components, you would take the 10 newtons and then this is 30 degrees. The vertical component would be 10 sine of 30 degrees, and then the horizontal component would be 10 cos of 30 degrees. Okay, so basically our horizontal component which is along the displacement is 30 cos 30 or 10 cos 30 degrees. Therefore work done is equals to, again, F dot ds, which is equal to 10 cos of 30 degrees times ds, which is again the same, which is 1.5. Therefore this becomes equal to 10 times cos 30 and 1.5. It's 12.99. We can say 13 joules. Okay. And lastly, for part C, we have a similar scenario, but in this case the force is actually being applied in the opposite direction. So this angle is 30 degrees. the displacement is towards the right. So when we do use this displacement, we would say that the force is being applied in the opposite direction. Therefore, uh, this is actually, the work would be negative in this case. Again, if we were to resolve this 10 Newton force into two components, we would have, let me just draw this a bit bigger. So it's okay, 10 newtons, then the vertical component and a horizontal component. So this is 30 degrees. This would be similarly 10 sine 30, and this would be 10 cos 30 degrees. Okay, so now again, this is the component of the force along the displacement, so we would use that to calculate work. So work is equals to F dot ds. In this case, the force is in the negative direction. So if we determine our coordinate axis to be y positive x negative x, the force is acting along the negative x direction. So we would say negative of 10 cos 30 degrees times 1.5. This would be exactly the same as the solution above, just negative in this case. So the answer would be negative 30 joules in this case. Okay, let's see what they've done. So work done is an integral of ds. Hence, displacement in the same direction. Correct. Work done for the first case is 15, and for second is 13, and then lastly it's negative 13. Perfect. So just by the definition of work done, just so you understand better, work done is the amount of force which you would need to apply in order to move an object 1 meter. So, or is the amount of work you would need to do to move it 1 meters. So for the last case, since it's moving in the opposing direction, our work done is actually negative. So in this case, the solution is correct. Okay, question 2. A motorcycle starts from rest and has a constant acceleration. When the motorcycle is accelerated for time t, it undergoes a displacement x and attains a final velocity v. If the motorcycle is accelerated with the same acceleration for so long that it attains a displacement 3x, what will be the final velocity in terms of v? Okay, so in this question, we have question 2. We have a motorcycle which is accelerating at, let's say, acceleration is equals to a, time taken is equals to t, and we know that it has a displacement of x. Okay, and we're even given the velocity for the first case. It's equals to v. So these are all the givens, and this is for case 1. Okay, so what we want to do is we want to establish relations and be able to find the velocity for the second case. So for case number 2, so this motorbike is still accelerating, but this time all we know is that the acceleration is still a, and the displacement is 3x, but we don't know what the time it would be, and we don't know what the velocity is, and we are asked to find the velocity. So in order to do that, let's write a few of these terms in the form of what we know. So for the first case, we can use the first equation of motion and say our acceleration would be equal to velocity over time. So this is for case 1. Similarly, for case 1, using the second equation of motion, we can relate the displacement with the acceleration of time. So the second equation of motion is S is equals to ut plus half at squared. Since the body started from rest, u is 0. So we get S, which is the displacement, which is equal to x, is equals to half at squared. Okay, and what's important to note here is that all of these terms, v, t, and a, were actually already given to us. So let's say this is 1, this is 2. Okay, for case 2, so now all of a sudden, so for case 2, my displacement is actually 3 times my initial velocity. So, or 3 times my initial displacement. So what I can say is, if I use the third equation of motion, which is v squared minus u squared is equals to 2as, I can say that in my case, s is actually equal to 3x. So let me substitute that in. So v squared, u, which was the initial velocity, is 0, and we get equal to 2a times 3x. So in this case, we are left with 6ax. But since the question specifically asks us to find the new velocity in terms of the original velocity, what we can do is, if we look here, we'd actually know the values of a and x in other forms as well. So what we can say is v squared is equals to 6 times a becomes b over t, and x becomes 1 over 2 at squared. Okay. Again, we can further substitute the acceleration because the acceleration is the same. So this gets cancelled and we get 3 VAT, and this is, let's call this V2 because it's the new velocity. Again, V2 squared is equals to, we can further substitute A back in, which is V over T, and we would get 3V squared. Let me show you the steps. So 3VA from 1, equation 1, we know A is equals to V over T. So we substitute that in and we get this. T's get cancelled, V becomes V squared is equals to 3V squared. Therefore, V2 is equals to root 3V. So the new velocity will have to be V, which is the original velocity, times root 3. So this is your final answer. So the important steps here to note is that you need to know the equations of motions, the 3 equations of motions, and then just split the question into 2 scenarios. Write down all the equations of motion for the first scenarios and the givens, and take the givens and use them in the second scenario and then solve the question. Okay, so let's see what they've done. So A is V over T is correct, X is Vt over 2, that's also correct. Sure, yeah. They substituted A here, which is fine. And then B1 is equals to 3V squared. So this is actually incorrect. So this should have been root 3V. The final answer is incorrect. The velocity is equal to v times square root of v, square root of 3. Okay, using the third equation of motion. Okay, so I'm going to mark that as incorrect. All right, question number 3. A box which is 15 kilograms is pushed 5 meters across a level floor, along which we have a coefficient of friction as 0.333. The push acts parallel to the floor. Determine the push required to accelerate the box from rest to 1.5 meters per second. Okay, so we have a floor on which we have a box. Okay, and this box is 15 kgs. We are pushing it with some force. We don't know that force, but there is a coefficient of friction. So this floor is not smooth. So there is a coefficient of friction of mu is equals to 0.333. Okay, but we do know that we were able to push this box 5 meters. Okay, and u, which is the initial velocity, was 0, and v, which is the final velocity, was 1.5 meters per second. Okay, so we need to find the force required. So essentially we need to get to acceleration first, and then we can use the acceleration to find the force. Okay, so if I use the third equation of motion, we know that v squared minus u squared is equals to 2as. This implies 1.5 squared is equals to, the initial velocity is 0, 2a, and s is also s is 5. Therefore, acceleration is equals to 1.5 squared divided by 10. It's 0.225 meters per second square. 0.225 meters per second square. So we know our acceleration. Now what we would do is we would draw the free body diagram of the box. Okay, so the box has a weight, so it has a normal force mg acting downwards. It has a normal force n acting upward because of the laws of motion, equal and opposite reaction. We are applying a force F to move this box in this direction, and we know that since there is a coefficient of friction, there is a friction force, let's call it small f, acting on the left hand side. Okay, so if we take equilibrium along the y-axis, we know that the normal force is equal to mg, so we know that. And what we can do is we can take equilibrium about the x-axis as well, and we would get summation of forces is equals to ma, which is equals to f minus small f. Okay, in this case we need to find capital F, so we would say capital F is equals to ma plus small f, which is the frictional force. The frictional force is equals to mu, which is the coefficient of friction, times n, which is the normal force. So we would say this is equal to ma plus mu n. N is equal to mg. So we would say this is equal to ma plus mu mg. And therefore this becomes equal to, let me substitute the values in. M is 15 times a, which is 0.225, plus mu was 0.333 times m again, which is 15, times g, which is 9.8 meters per second squared. Therefore, the final answer becomes 15 times 0.225 plus 0.333 times 15 times 9.8, 52.326 newtons. Okay, which essentially means that we would need a force of 52.3 newtons in the right direction in order to move this box 1.5 in order to move this box 5 meters at a speed of 1.5 meters per second. Okay, so let's check the answer. So we state all the givens first, then we find the acceleration, which is given by the equation of motion. We get 0.225, which is correct, and then we take the forces of motion in the x-axis, and the final answer is 52.4. So that's correct. So this answer is correct. Okay, let's proceed to question number 4. So question number 4 is saying 73 kg skier is traveling horizontally with a speed of 28 meters per second at the top of an 18-degree incline. He slides 122 meters down the incline, reaching a speed of 35 meters per second, where there is no friction between the skier and the horizontal surface. So initially, this surface has no friction. So we need to find the coefficient in the incline. Okay, so let's copy this question over. Okay, so the box here represents the skier. So this is 73 kgs. We need to find the coefficient. So this incline has a mu, which we need to find. Okay. So what we can do is, all right. So we know the initial velocity of the skier when he is almost at the incline. So the initial velocity is equal to 28 meters per second, and we also know the final velocity, which is equal to 35 meters per second. Okay, and we know that the distance traveled is equal to 122 meters. From this information, we can calculate the acceleration which was observed. So we can say that v square minus u square is equals to 2as. V is 35, so 35 square minus 28 square is equals to 2a, and s is equal to 122. Therefore, the acceleration is equal to 35 square minus 28 square divided by 2 times 122, which is equal to 1.8. So we get the acceleration to be 1.8 meters per second square. So essentially what that means is the skier was traveling on the horizontal surface, and then as soon as he or she hit the downward decline, they started accelerating at an acceleration of 1.8 meters per second square. Okay, so in order to find the coefficient in the incline, what we can do is we can draw the free body diagram of the skier. Okay, so if the skier is like this angle is 18 degrees. We know that there'll be a normal force or a force acting downward, which is the weight, which will be mg. And there is always a normal force acting from the contact to the surface. we know that there will be a friction force which will try to resist the motion of the skier on the snow, which would be small f. And then at the same time, we know that there is two components of mg which we can divide it to. So we have this component which is mg cos of theta, where theta is 18 degrees, so cos of 18 degrees. And then we would have a component of mg acting along or parallel to the incline as well, which will be mg sine of 18 degrees. Okay, so if we take sum of forces along the normal direction, we get normal is equals to mg cos of 18 degrees. And now if we take sum of forces along the other axis, the axis along the decline, we know that this is accelerating in the downward direction. So we can say that F is equals to, or with MA, which is equal to mg sine of 180 degrees, or 18 degrees, sorry, minus the friction force. Okay, so MA is equals to mg sine of 18 degrees minus the frictional force. Frictional force is given by coefficient of friction times the normal force. In this case, the normal force is equal to mg cos of 18 degrees. Okay, we know all the parameters here, so we can go ahead and solve for mu. So the m's get cancelled, and we're left with a, which we calculated was 1.8 meters per second squared, is equals to 9.8 times sine of 18, which I'll calculate, sine of 18 degrees minus mu times 9.8 times cos of 18 degrees. Okay, so we get 1.8 minus 9.8 times sine of 18, which is negative 1.22. So we get negative 1.22 is equals to negative 9.8 times cos of 18, which is equal to mu times 9.32. Okay, so the negatives get cancelled and we get a mu of 1.22 divided by 9.32, which is equal to 0.13. Okay, so that would be the coefficient of friction in the incline. And then for the second part, the mechanical energy lost by the skier due to the kinetic friction only. So this is essentially asking us for the work done by the kinetic friction. So that is simply equal to the force times the distance traveled. Yeah, let me make sure that the first part was correct, 0.31, and then the second part is essentially the force times the distance traveled, the force due to the friction force. So work done is equal to frictional force, which is small f, times d. As we know that the frictional force is equal to the normal force, so mu times the normal force times d. Normal force is equal to mg cos of theta. So mg cos of 18 degrees in this case times d. Therefore, the final value would be 0.13 times mass, which is 73 times 9.8 times cos of 18 degrees, oops, times d, which is the distance traveled, which is 122. So this value is equal to 0.13 times 73 times 9.8 times cos of 18 times 122. So this is a pretty big number, 10,790. And since the frictional force and the displacement are in opposite directions, this would be a negative value. So this is the amount of energy which was lost due to this gear because of the friction. Okay, let's check the answer. So we use the equation of motion to calculate A, which is correct, 1.8. And then we do the sum of forces and we get the mu, which is 0.13. For the second part, we get the kinetic friction. So we get 1.08. So it's fairly close. I'm not sure why the answers don't match exactly, but I think it might just be a calculation error. But the principle is correct. Okay, so the solution is correct. Okay, so I think that's it for today's class. I hope you enjoyed the session. If you found it of any value, please feel free to like, comment, and subscribe to OneClass. If you have any questions, you can post them in the comment section, or you can check out the link in the description and reach out directly to us. Thank you so much. This has been Nehel, and I hope you have a great day.